Hi guys, welcome to this presentation in differentiation. I wonder whether you've heard this saying, the whole is greater than the sum of the parts. Well, in this particular example, we're going to be working with a champion rule. It's called the chain rule, and it works with the whole of a function and it breaks it up into two easy to digest and differentiate components. So we're going to decompose complicated functions. That's what the chain rule is about. The chain rule is actually a chain of two functions that are linked together just like a chain. Sometimes it's called a function of a function rule in some textbooks. So let me just give you the rule on generally how it works, and there's a variety of ways that a variety of textbooks express these rules. There's a variety of variables and pronumerals, but essentially the concept and principles of the chain rule remain the same. So regardless of whatever textbook you're using or whatever notation your teachers are using, this function of a function or chain rule works essentially the same. And it's quite simple once you break it up into its and decompose a complicated function into its two smaller components. So let's have a look at the first rule here of the chain rule. We have here dy dx equals dy du times or multiplied by du dx. Now you might notice that we have this u we've just introduced out of nowhere, and that u is over here. You might notice there's a du here and a du there, and if we cancel them out, what do you think we're left with? If the two du's are gone, we're going to be left with a dy dx. So we're back to what we were here. So essentially this rule takes something a whole and breaks it up into two components, and that's the function of the function. So one of the best ways for you to start to understand and gain more clarity for the chain rule is for us to do an example, as you can see it being done. And the more examples you see, the easier it'll be for you to digest and absorb. So let's do an example so you can see how we break up a function of a function. So we have a function here, a complicated function, and it's y equals 5x plus 2 all to the power of 3. Now we can't use the old rule to do this because the old rule was the power rule. You remember the original rule, the power rule? We just bring the power down and then we differentiate it. But it won't quite work because we have a function inside those brackets, and we have the outside function where y equals the function to the power of 3. Let me just do this example as it starts to make more sense. Now some of you are probably wondering, I'm not sure what you mean or how that works. But just be patient, this will start to make more sense as we do more examples. So let me just get stuck into this and break it up into its two components. So the first thing I want to do is just introduce the letter u. As you saw up here, we have the letter u. So we're going to let u equal something. So let u equal, well, what does u equal? Well, let's let u equal that inside part of the function. So that's we've decomposed it to the inside part. So u equals, that's one part of the link of the chain. So let's look at the other part of the link. Well, the outside part, because that's the inside, is the y part here, where we have y equals, and the inside part, well, that's the u, as you can see, that's the 5x plus 2. So let's call it u. There's the inside part to the power of 3. Okay, so let me just write out next to it so you can kind of see how this is working. This is the outside, and this is the inside. Okay, let's have another look here. We have the outside, y equals brackets to the power 3, right there. And the inside, the guts of these brackets in here, 5x plus 2, that's the inside there. So what do we have? A function of a function, the chain rule. Function and function together, linked together, just like a chain. That's where they get the name chain rule. Okay, so what do we do now? Well, it's kind of like the power rule, but we just follow this and we'll be able to do it. That formula works quite well. Well, let's find what dy du is first of all, because we've got the two components. Let's work with the one on the left. Dy du, well, we know what y is, so what's dy du going to be? Let's simply find the derivative of that. Well, if y equals u to the power of 3, dy du, well, we're going to use the power rule for that. 3u, and then drop the power by 1. Remember, 3 minus 1, that'll be 3u squared. It's just like the power rule. We're only working with that part, the outside part. Now let's go for the inside part. Right over here, it's du dx. Now we already found what u is because we let u equal 5x plus 2. So let's do that now. Let's do du dx. What's that going to equal? Well, if u equals 5x plus 2, then du dx, if we differentiate that with respect to x, it's simply just going to be 5. Remember 5x, if you differentiate 5x with the power rule, it's just 5, right? There's our 5. So now we have these components over here. We put a line there. We can simply take these and slot and substitute them into this formula here on the left. So let's work this out. So dy dx is equal to dy du. Now what's dy du? That's right over there, 3u squared. 3u squared, there we are there, dy du. Next we're going to multiply by what's on the right hand side. As you can see here, it's du dx. Let's go to du dx, we worked it out earlier. Du dx right here equals what? Equals 5, so let's put that over here. So it's times 5. Now, this part over here, see that u? We know what that u is, don't we? Because that u is 5x plus 2, isn't it? We're going to bring that in later on, so just keep your eye on that. But for the moment, let's simplify this. This equals, dy dx equals 3 times 5. You multiply this times the outside, so that's 15u squared. There's that u again, remember I said from before? You mark it out. Now what's that u equal? Well, u equals 5x plus 2. So let's go back and slot and substitute that back into the original again. So, the differential, the derivative of this composite function right over here, this complicated function, equals dy dx equals 15. Let's put that u back. Where's the u? U is what? 5x plus 2, isn't it? So let's put it back there. 5x plus 2. There's our u there. Let me just mark it again. That is there. Now don't forget we have a little squared on top here, so we're going to put that over here. And that is the derivative for this complicated function up here. Now stay tuned, I'm going to do another video lesson whereby I'm going to find the answer, the derivative to this one, using the right-hand rule over here. It's very similar to this, almost identical, it's just different language around the same function of a function. So stay tuned and watch the next video.